Right then, analog electronics. Here I have a circuit with a transistor and it's switching on a bulb with something to do with the heat. You have to be able to explain these circuits in the terms of input, process and output. The input is a voltage divider. That's a thermistor. As the temperature goes up, the resistance of the thermistor goes down. If you don't remember that, you look in the data booklet and you see the graph. Okay. So as temperature goes up, the resistance goes down. So if it's hot, the voltage, resistance of there will be small. So that means the voltage there will be small. Temperature up, resistance down, so the voltage there will be down when it's hot. So as the temperature goes up, the voltage here will also go up. So in the hot, V out is big in this, with this configuration. The 2K adjusts the sensitivity of the circuit. That's all it does. That 1K protects the base of the transistor from excessive currents. If that resistance goes very small, it would be like putting the 12 volts straight on the base if that resistor wasn't there. It's usually 1K. The transistor amplifies the signal and it acts as a switch. When the transistor saturates, this voltage here, VBE, is 0.7 volts. That's a saturation voltage. It's in the data booklet. So there's a small current here. There's a big current to switch on the relay. That diode protects the transistor from a back EMF caused by the relay. The relay lets a low voltage system switch on a high voltage system. Okay. 12 volts is controlling 240 volts AC. So that when it's hot, this 240 volt bulb goes on. Now, if you're given a temperature, you can work out the resistance of the thermistor from the data booklet. Let's say I've looked in the data booklet and the resistance there is, let's just say 2K to keep things easy for me. We then need to find this voltage here. The total resistance between the 12 and the 0, in this case is 2 plus 2. So R equals 2 plus 2, so that's 4K. I equals V over R, so it equals 12 divided by the total resistance, which is 4, so that's 3 milliamps. So now I've got 3 milliamps at the top. In standard grade, just assume there's 3 milliamps going down there as well. So it's 3 milliamps, so the V is I times R, so that's 3 times 2, it's 6 volts. So that voltage would be 6 volts. When the transistor is switched on, that's 0.7 there. That's 6 there. That voltage there must be 6 minus 0.7. If you imagine walking, you're at the bottom of a hill, you climb up 0.7 there, you can see this bit is 6 volts, so as you're looking across, you're seeing 5.3 up. This is the base current, this is the collector current. The current gain, a thing called HFE, is IC divided by IB. Okay, it's around about 100 usually. Now, this relay is a single pole, single throw. Here it is again, single pole, single throw. Here I have a single pole, double throw. Okay, I could have a motor on this one, and a lamp on that one. Okay, we can throw on two different things. 0 volts. This one, the double pole, double throw, it's used for connecting to a motor often. So how I've got it drawn just now, the negative side of my battery is attached to this side of the motor. Now, if we flip the switch, if I connect that there, and that one there, Right, if you imagine that flipped, the negative side will be attached here, okay, and the positive side will be attached on the other side. So the double pole, double throw switch lets you control the direction of a motor. We've got two resistances in series. The total resistance is R1 plus R2 plus R3 plus R4. In this case, 10 plus 20, so that's 30k. This one here, these two are in parallel. That one's in series with the two parallel ones. To calculate the resistance of these two, there's two ways of doing it. In the product, R1 times R2 over R1 plus R2. Doesn't matter which order you do them in, so it's 20 times 5 over 20 plus 5. When you're doing it on your calculator, do the intermediate steps, or you'll go wrong. There's another way of doing it. You use the 1 over RT button, 1 over R1 plus 1 over R2 plus 1 over R3, 4, whatever. And then you can, at the end of that, press the 1 over X button again, and you'll get the answer. The answer will always be less than the smallest resistance. 100 divided by 25 is 4k. So these two are equivalent to having a 10k and then a 4k. So it's a 14 altogether. We've got two circuits here with lights. 3 of them are in parallel here and 3 are in series. If one of these bulbs fails, the circuit's broken. They all go out. Don't buy Christmas lights like that. On this one, if a bulb fails, there's still connections. The other ones will stay on. If these bulbs are all identical, let's just say that one takes 60 milliamps, that one takes 60 milliamps, and that one takes 60 milliamps. If you think of that point there, there's 60 flowing down here, there's 60 flowing there. So there must be 120 milliamps there. Here, at that point, there's 120 going that way, 60 going that way, so you must have 180. So the current being drawn from the battery is 180 milliamps.